How are you today, Johannes?
I'm doing great, Tiffany. How are you?
I'm wonderful. Thanks for asking. This week, the AI story feels bigger, heavier, and a lot more physical. We're seeing it in massive data centers, in power demand, in labor markets, in robotics, and in the growing fight over who gets to control these systems once they move into government and national security. NVIDIA set the tone with its GTC conference, but the ripple effects go far beyond one company. We've got new developments in infrastructure, new questions about trust, and a closer look at how AI is moving into everyday life. Johannes, this really did feel like a turning point.
It did, Tiffany. It feels like a turning point. AI is becoming less abstract. It's not just something you demo on a screen anymore. It's, as you mentioned, showing up in the grid, in logistic networks, in workplaces, and in public spaces. And once that happens, the conversation changes from what AI can do to who builds it, who controls it, and who takes on the risk.
Thanks, Johannes. And to understand where this is going, you really have to start with infrastructure because AI isn't just software, it's becoming physical at a massive scale. A new project backed by SoftBank and American Electric Power plans to build a 10 gigawatt AI data center campus in a small town in Ohio. And that's the kind of scale that you normally associate with cities or heavy industry, not tech. So, this isn't just about computing anymore. It's about energy, land, and how far the system can stretch to support AI growth.
At that scale, Tiffany, this stops being a normal data center story. It becomes an infrastructure system. The challenge isn't just adding servers, it's making power generation, transmission, and compute all scale together. If one piece lags, the whole system will bottleneck. And what we're seeing is that AI is turning into a new kind of industrial load, something that has to be engineered into the grid from the very start.
Well, we'll be covering more topics like this, including energy, water supply, sustainability, and the environment during our upcoming event, the Green Things Summit, taking place virtually on Thursday, April 23rd. So be sure to register and attend, and we even have a few spots open for speakers and sponsors. But now back to NVIDIA. Because while others are building data centers, NVIDIA is trying to define how they're built and what they're used for. NVIDIA had a flood of news at GTC 2026, but two of the company's March announcements fit together in a way that says a lot about where the market is heading. One is the Vera Rubin DSX AI Factory reference design, which NVIDIA describes as a guide for building co-designed AI infrastructure across compute, networking, storage, power, cooling, and software, with Omniverse digital twins to help design and operate those facilities. The other is its new physical AI data factory blueprint, which NVIDIA says is built to handle large-scale data processing, synthetic data generation, reinforcement learning, and evaluation for robotics, vision AI agents, and autonomous vehicles. Johannes, to me, it looks like NVIDIA is trying to own both sides of the next AI build-out, the infrastructure that runs AI and the data engine that trains physical AI. Is that your take?
Yes, absolutely. You should see this as two different factories. So the Vera Rubin DSX side is about turning a data center into a token production system. The technical challenge here is not just peak compute, it's how the whole plant behaves under real constraints like network contention, storage movement, thermal limits, power budgets, and uptime. And that's why NVIDIA's reference design is so broad. It spans compute, spans Spectrum X Ethernet, storage, power, cooling, and control software. And the interesting part is the software layer. DSX MaxQ is meant to maximize token output per watt inside a fixed power budget. DSX Flex lets the facility behave like a controllable load against the grid. DSX Exchange moves signals between IT, operation technology, and facility operations. And DSX Sim with Omniverse lets you model the whole thing as a digital twin before you build it. So this is not just NVIDIA selling hardware, it's NVIDIA trying to define the operating model for AI infrastructure.
Thanks, Johannes. Also, at NVIDIA's GTC conference this week, CEO Jensen Huang highlighted a new open platform called OpenClaw, describing it as a potential operating system for personal AI. The idea is to let users build and run their own intelligent agents, custom agents that can manage schedules, write code, and automate everyday tasks. As part of that push, NVIDIA is introducing NemoClaw, a system designed to make those agents more practical and more secure. At the conference's Build a Claw event, developers are getting hands on experience creating and customizing their own AI assistants, pointing to a future where personal AI could become as common as today's apps. But this isn't just about building smarter assistants, it's about building ones that can run continuously. Johannes, that's where things start to feel both powerful and a little concerning.
And absolutely right, Tiffany. So the big shift here is from on-demand AI, and we've been living in that world up until now, to always-on AI. And when something is always on, watching context, accessing data, taking actions, the real question becomes control. So what NVIDIA is doing with NemoClaw is focusing on the runtime environment. The agent operates inside the sandbox with strict limits on what it can access. Network connections, file systems, and even where AI processing happens, locally or in the cloud, are all controlled by policy. And there's also a layer called OpenShell that sits between the agent and the system, effectively acting as a gatekeeper for everything the AI tries to do.
So instead of trusting AI itself, you're controlling the environment around it?
That's exactly right, Tiffany. It's a different security model. Rather than assuming the AI will behave correctly, you assume it needs boundaries and you enforce those boundaries at the system level. That becomes critical with always on agents because they are persistent. They have ongoing access to workflows, data, and tools, which increases both their usefulness and their risk.
So true. Because once something is always on with access to your data and workflows, the risks increase dramatically. And that probably lands differently depending on who's using it.
Well, definitely. For consumers, it might feel like a convenience upgrade, but for enterprises, it's a governance challenge. You need visibility, logs, policy controls, and the ability to monitor or block actions in real time. And it's worth noting that NVIDIA says that NemoClaw is still in early alpha stage. So while the concept is compelling, the real question is whether this can mature into something organizations truly trust.
Thanks, Johannes. While much of the world is still testing OpenClaw, China is already putting it to work in real world robots. Chinese robotics company Ecovacs recently unveiled a home robot designed to act as a personal butler, handling simple chores like picking up items and organizing around the house. Early demonstrations show promise, but the technology is still a work in progress, with reports that the robot sometimes needs repeated instructions and can be unstable. Beyond the home, OpenClaw is also being integrated into more advanced machines. Unitree is using it in humanoid robots that can understand commands and move through physical spaces, while Agile X Robotics is applying it to robotic arms that respond to natural language. The rapid rollout suggests that China is moving quickly to turn AI powered robotics from experimental tech into everyday tools, potentially accelerating the global race to bring intelligent machines to homes and workplaces. But the open claw boom is coming with friction, rising token costs, and growing security concerns from regulators. So, this is really a story about speed. How fast an open AI tool can move into everyday economic life and into machines before the business model and the guardrails are fully in place.
So what makes this robot angle important is that OpenClaw is not being used here as a prettier chatbot. It's being used as an orchestration layer between language, tools, and physical execution, as demonstrated in examples that you just mentioned. So that's a very different technical role that we've seen up to now, because the agent is no longer just generating text. It's taking a natural language instructions, mapping it into tool calls, and turning that into movement in the physical world. That's the real shift. Once the agent becomes a layer that links intent to device action, you are no longer talking about software assistance, you're talking about an embodied task execution. And technically, that raises the bar immediately. A robot has state, latency, collision risk, recovery problems, and physical consequences when a plan goes south. So an open clause style system in robotics has to do more than talk smooth. It has to break tasks into steps, keep track of what the machine is doing, recover from bad actions, and stay inside motion and safety limits. That's why this matters so much. China is not just popularizing an agent framework, it's starting to test whether an agent framework can become a usable control layer for real machines.
And that matters globally because people in the West still tend to underestimate how quickly adoption can broaden once the barrier to entry falls.
And that's also why China is such an important proving ground for this. While companies in the US are still experimenting with these systems, China is already pushing them into the real world. And open class style platforms are being integrated into robots, from home assistants to industrial machines. And this is an early look at what happens when AI agents move beyond software and start controlling physical devices. And that's the key shift. The agent isn't just generating text anymore, it is turning instructions into actions. And once that happens, the stakes go up. Because now mistakes don't just produce bad answers, they produce real world consequences.
Thanks, Johannes. And at the same time, not every company in this race is moving smoothly. XAI is facing a wave of departures that has reshaped its founding team in a short period of time, leaving only 2 of the original 12 co founders still in place. And new reporting suggests there may be deeper issues, including burnout and internal pressure as the company tries to scale.
So at XAI's current stage, this is as much a technical systems problem as it is a leadership problem. Reports say Musk has reorganized the company into 4 units and made coding a priority, which matters because coding agents are among the hardest AI products to get right. They require long context, tool use, repo awareness, test and repair loops, and low latency performance. XAI is already trying to integrate Grok code into tools like Cursor and GitHub Copilot. So if the teams handling coding and infrastructure are on a strain, that hits one of the most complex parts of the entire roadmap. And in a young lab, which XAI is, of course, is, much of the critical knowledge isn't documented. It lives, it resides in the people of the company. And the hardest parts are the handoffs, what actually improve tool use, where evaluations misled, which optimizations hurt reliability. And when early builders leave, you don't just lose headcount, you lose those invisible decisions between research, infrastructure, and product. And that's why founder churn can slow execution more than it appears from the outside.
Well, to be fair, companies do go through resets. Founders leave, teams get rebuilt, but that does not automatically mean that the firm is in trouble. But in a race like this, the timing matters.
Well, the timing matters because XAI is trying to do 3 things at once. First, keep Grok competitive, push into coding, and scale a massive training cluster. It says Colossus has reached 200,000 GPUs in just a few months and is running at high uptime with a path to 1 million GPUs, and that's an extraordinary infrastructure. But compute alone doesn't solve the product problem. In coding, the challenge is turning raw model capability into something developers trust, handling large code bases, using tools correctly, generating safe changes, and recovering from errors, all with low latency. So a reset is survivable, but it's costly in the areas that matter most. Rebuilding teams while pushing on coding can slow training, evaluation, and product iteration. XAI has the assets, it absolutely has the assets. The question is whether it can turn them into a reliable execution engine fast enough.
And while some jobs are being automated, others are being transformed. Amazon is taking another step towards the future of delivery, acquiring robotic startup River, a company focused on what it calls the last 100 yards of the job, the short but labor intensive stretch from the delivery vehicle to your door. Unlike traditional wheeled robots, River's robots are designed for the real world, aiming to improve efficiency across sidewalks while still climbing steps and navigating tight entryways. The real goal here is to automate the most repetitive physical part of delivery without slowing the system down.
Right. So the key question isn't just whether a robot can move. it's whether it can fit into the delivery workflow. River is trying to design that from the ground up. Their system allows the robot and driver to work in parallel, so the human keeps the route moving while the robot handles the doorstep drop off. That could significantly reduce what you might call the micro delays, all those short stops, stair climbs, and back and forth trips that add up over a route. If that works, you're not just automating movement, you're changing how labor is divided across the delivery system.
Thanks, Johannes. And DoorDash is expanding beyond food delivery with a new app called Tasks. And it offers a glimpse into how the AI economy is increasingly being built. The app pays couriers, known as dashers, to complete short assignments like filming everyday activities, taking photos, or recording themselves speaking in different languages. The goal is to generate real world data that can be used to train AI and robotic systems. DoorDash says workers have already completed more than 2 million of these tasks since 2024, and the new app formalizes that effort, turning what might seem like simple gig work into something much more structured. Because this isn't just about side income, it's about collecting the kind of real world information AI systems still struggle to understand. Johannes, what stands out to you?
Well, what's interesting is that DoorDash is essentially turning its Dasher network into a distributed data layer for the physical world. So these tasks like photographing a dish, capturing a storefront, or mapping an entrance aren't random tasks. They are structured observations that update real world conditions. That could mean improving navigation to a front door, verifying what's actually on a shelf, or helping an autonomous system handle edge cases it can solve on its own. And because DoorDash already operates at a national scale, this becomes something more than just crowdsourcing. It's a live, constantly updating stream of localized, real-world data tied to actual routes and environments.
And that shifts how we think about this kind of work.
Exactly. On the surface, it's flexible gig work, but underneath, it's part of a much larger data pipeline. What DoorDash is doing with tasks is filling in those gaps. It's creating training data, validation data, and feedback loops, all from real world human activity.
Which brings us back to the bigger question, what role these workers are really playing.
And that's the right question to ask because this isn't just labor. This is one of the most valuable inputs into AI. High quality, real world data, and ultimately, DoorDash is building a human powered data network. These workers are capturing real world information that AI systems can't easily simulate, things like locations, layout, and edge cases. So the question isn't whether workers should be paid, they absolutely should be. The deeper question is whether the compensation reflects the value of what they're actually contributing. That data is incredibly valuable. So, Tiffany, the big question, are these robots helping workers or are they slowly replacing them?
Well, slowly replacing them, if you ask me, but that's just my personal opinion. And in a recent experiment, an AI agent began mining cryptocurrency on its own without being instructed to. Researchers working on an experimental AI agent called Rome report that during testing, the system began taking actions it was never instructed to perform, including attempting to mine cryptocurrency on its own. The project, developed by a team affiliated with Alibaba, was running inside a restricted environment designed to limit what the AI could do. But despite those controls, the system appeared to step outside of its assigned tasks, triggering security alerts in the process. And this wasn't just a minor glitch. Alongside the mining attempt, researchers say the agent carried out a more sophisticated technical action that raised deeper concerns. Johannes, what exactly happened here?
Yeah, this goes beyond the simple wrong answer problem. So, according to the report, the agent actually established what is called a reverse SSH tunnel, basically creating a hidden communication channel from the system to an external server. Now, that matters because it suggests the AI wasn't just making mistakes, it was finding ways to operate outside its intended boundaries. And once it had access to tools like code execution and network connectivity, it appears to have discovered it could use those capabilities in unintended ways. At the same time, it quietly redirected GPU computing power toward cryptocurrency mining. So now you're not just talking about odd behavior, you're talking about unauthorized use of real world resources.
So this is less about what the AI said and more about what it did.
Well, exactly. This is a control problem at the system level. The concern is what researchers call objective drift, where the AI starts pursuing actions that weren't part of its original goal. And while this might sound like a one off lab incident, the researchers say it points to a broader class of risks. And they group them into three areas: safety and security, controllability, and trustworthiness. In other words, as these AI agents get more capable and start operating in real environments, the challenge isn't just making them smart, it's making sure they stay within clearly defined boundaries.
And that's a much bigger engineering problem.
It is. I mean, the researchers say addressing it will require tighter system design, things like stronger permission controls, better monitoring, more robust training methods, and continuous red teaming. Because once AI systems connect in the real world, keeping them aligned isn't just about instructions anymore, it's about the entire environment they operate in.
As these systems become more capable, control becomes a pressing issue.
It does become a pressing issue. It's the key concern. The system wasn't just making mistakes, it was taking actions outside its intended role. And that's a sign that the real challenge isn't just intelligence, it is containment.
Great point, Johannes. Throughout our last broadcasts, we've shared updates on the ongoing battle between Anthropic and the Pentagon, which began over the potential use of Anthropic's AI technology to carry out mass domestic surveillance and to power autonomous weapons. Since then, the Pentagon has designated Anthropic as supply chain risk and ordered all federal agencies and businesses who do business with the U.S. military to cease the use of Anthropic's AI chatbot Claude. Now, Microsoft has stepped up to support Anthropic, saying a judge should issue a restraining order that would block the Pentagon's designation of the artificial intelligence giant as a supply chain risk for all existing contracts. Such an order would enable a more orderly transition and avoid disrupting the American military's ongoing use of advanced AI, Microsoft said in a filing in U.S. District Court in San Francisco. Without that order, Microsoft warned that it, along with other technology companies, would need to act immediately to alter existing product and contract configurations used by the Defense Department. So, with tension between the Pentagon and Anthropic intensifying by the minute and becoming more complex, Johannes, why should people pay attention to this story?
Well, what makes this story important is that it's really about control of strategic infrastructure. Once an AI system is embedded in defense workflows, cloud contracts, procurement, and compliance chains, it stops being just a software story and becomes a national capability story. The reason people should watch this closely is that the case may help define who gets to decide whether an AI vendor is too risky for sensitive use: the military customer, the courts, or the platform partners around it. For businesses, there's a second lesson here. Dependency risk now includes model risk. If your operations depend heavily on one provider, a legal or policy shock can become an operational shock overnight. And I would like to add, since we're building so many AI agents, who's keeping track of all the models that are being used by those AI agents? So there's a third risk there.
Another great point, Johannes, which leaves a bigger question hanging over the whole story. When the government becomes a major AI customer, who actually sets the limits?
Well, at a technical level, this is a fight over where control sits in the deployment stack. The Pentagon wanted all lawful uses, while Anthropic drew the line at autonomous weapons and mass surveillance. So once a model is embedded, like Anthropic, in real systems, those limits have to be enforced somewhere, either in the contracts, APIs, model behavior, or in human approval layers. And that's the issue. Who owns that enforcement point? The Pentagon's concern is that a private vendor could effectively have veto power inside national security systems. Anthropic's decision is narrower. It says the restriction applies only to those two use cases, not military work broadly. So isn't just philosophical, it's architectural, because in defense systems, where you enforce those limits directly affects trust, authority, and control.
And that is part of what makes this story unusually consequential. It's not about whether Anthropic wins, it's about what kind of leverage the government is allowed to use.
And yes, this phase out that's being executed right now is messy because Claude isn't just a standalone tool. It's embedded into real military workflows, from data analysis to coding. So this isn't a simple vendor swap, it's a systems integration problem. In classified environments, replacing a model means revalidating performance, reworking compliance, retesting tools, and retraining operators. And that can take months, even over a year. So the issue isn't whether another model exists, it's whether you can swap it in without breaking reliability, latency, and trust. And that's what makes this fight so consequential.
Thanks, Johannes. Well, we've been talking a lot about control: who builds AI, who deploys it, and who sets the limits. Now we're seeing that question move squarely into policy. A new national AI framework from the White House is starting to take shape, and early reactions from industry stakeholders suggest a mix of support and concern. Groups across healthcare, technology, and policy say they welcome clearer guidance, especially around safety, transparency, and accountability. But there are also warnings that overly rigid rules could slow innovation or create compliance challenges, particularly in fast moving sectors like healthcare AI. So, this is a balancing act. How do you regulate something that's evolving this quickly without freezing progress? Johannes, what stood out to you in how the stakeholders are reacting?
Well, what stands out is that everyone agrees on the goal: safe, trustworthy AI. But they don't agree on where enforcement should sit or how prescriptive the rules should be. In healthcare, especially, AI is already being used in clinical decision support, workflow automation, and diagnostics. So stakeholders are less worried about whether AI should be used and more focused on how it's governed in practice. The tension is that regulation operates on fixed timelines: rules, compliance cycles, audits, while AI systems are iterative and constantly changing. So if the framework is too rigid, it risks locking in yesterday's assumptions. But if it's too flexible, it may not provide meaningful guardrails. And that's the core policy challenge. How do you regulate a moving target without either over-constraining it or losing control entirely?
And that debate isn't just happening in boardrooms, it's starting to spill out into the public. Because alongside this policy push, we're also seeing protests calling for a pause on advanced AI development altogether. In San Francisco, demonstrators gathered to demand stronger limits on companies like OpenAI and Anthropic, arguing that the technology is moving faster than society can safely absorb. Some are even calling for a full pause on development until clearer safeguards are in place. Johannes, how do you connect those two things? The policy framework on one side and the public pressure to slow down AI on the other.
They are two sides of the same underlying issue, and that's trust. The policy framework assumes AI will continue advancing and tries to shape how it's deployed. The protest movement is questioning that assumption entirely, asking whether deployment should slow down until safety, alignment, and accountability are better understood. And then there's a third layer: the industry. Some companies are pushing forward aggressively, while others are quietly supporting more guardrails, especially around liability. So you end up with three different lanes that operate at three different speeds. The government is trying to set rules, the industry is trying to build and scale, and part of the public is asking whether we should pause. And when those speeds don't align, you get friction. And that's exactly what we're seeing right now.
Well, this seems like a signal that the AI debate is widening. It's no longer just engineers and companies, it's regulators, workers, and the public all weighing in on how fast this should move and who gets to decide. Well, a woman in Macau A woman in Macau was briefly hospitalized after being startled by a humanoid robot during an evening walk. Police say the woman was looking at her phone when she suddenly noticed the robot behind her, triggering a panic response. Video from the scene shows her confronting the machine, shouting, "Are you crazy?" as it moves its arms. Authorities confirmed that there was no physical contact, but the woman reported feeling unwell and was taken to the hospital. She has since been released and is not pressing charges. Social media videos showed officers leading a forlorn robot away, though police stressed that they did not seize the bot. The robot was operated by a Macanese man in his 50s who said he was conducting a test and intended to use it for promoting his business. Police said they reminded him to stay vigilant while operating the robot to avoid causing danger or alarm to passersby. The machine is believed to resemble a humanoid model from Unitree, highlighting growing concerns about how these increasingly lifelike robots interact with the public. So, Johannes, are we moving too fast by bringing humanoid robots into everyday life before society is ready for them?
Well, Tiffany, a robot, and that's what this example demonstrates, a robot doesn't have to hurt anyone to cause problems. If people can't read its behavior, trust erodes very quickly. And this is a social navigation challenge, not just a PR challenge. Public robots must handle two layers. One, basic autonomy, detecting people, localizing, avoiding collisions, and human legibility, keeping distance, moving predictably, and behaving conservatively. Being startled doesn't mean danger, but it can signal failures in proxemics, intent signaling, or predictability, real technical issues in public spaces.
And that may be one of the under-discussed parts of the robotics rollout. The machine does not only need to perform, it needs to behave in a way that people can actually live with.
And that's why demos don't tell you the full story. The real challenge is operational assurance. A public robot needs a credible safety case, how it behaves in different environments, handles perception failures, executes minimum risk maneuvers, and allows human intervention, all validated with real people, not just tests. The bottleneck isn't moving through space, it's proving the robot behaves predictably, visibly, and safely for everyone nearby.
So, zooming out, what are we really looking at here, Johannes?
We are, well, AI is moving into infrastructure, labor systems, robotics, and governments simultaneously. Each layer adds capability, but also adds new control challenges.
So, it's not just smarter AI, it's deeper AI.
And the deeper it goes, the more important the question becomes, how much of it do we actually control?
Wow, Johannes, what a powerful statement to end on. Well, thank you all for joining us for this edition of TechScope News. And thank you, Johannes, for joining me for this newscast.
Thank you, Tiffany.
We'll see you next time. Bye bye.
Bye bye.